Hello and welcome to the Data Engineering Podcast, the show about modern data management. Introducing RudderStack Profiles. RudderStack Profiles takes the SAS guesswork and SQL grunt work out of building complete customer profiles so you can quickly ship actionable, enriched data to every downstream team. You specify the customer traits, then Profiles runs the joins and computations for you to create complete customer profiles. Get all of the details and try the new product today at dataengineeringpodcast.com/RudderStack. Modern data teams are using Hex to 10x their data impact. Hex combines a notebook-style UI with an interactive report builder. This allows data teams to both dive deep to find insights and then share their work in an easy-to-read format to the whole org. In Hex, you can use SQL, Python, R, and no-code visualization together to explore, transform, and model data. Hex also has AI built directly into the workflow to help you generate, edit, explain, and document your code. The best data teams in the world, such as the ones at Notion, AngelList, and Anthropic, use Hex for ad hoc investigations, creating machine learning models, and building operational dashboards for the rest of their company. Hex makes it easy for data analysts and data scientists to collaborate together and produce work that has an impact. Make your data team unstoppable with Hex. Sign up today at dataengineeringpodcast.com/hex to get a 30-day free trial for your team. Your host is Tobias Macey, and today I'm interviewing Gleb Mezhanskiy and Rob Goretsky about when and how to think about migrating your data stack. So, Gleb, you've been on a few times, but for folks who haven't listened to any of your past appearances, if you'd like to give a brief introduction.
Hi, Tobias. Great to be back. My name is Gleb. I am CEO and co-founder of Datafold. We automate data testing. Before starting Datafold, I was a data engineer pretty much my entire career, companies including Autodesk and Lyft. And the topic of migrations is near and dear to my heart as I spent 2 years helping Lyft migrate from one data warehouse to a more scalable data lake, and definitely lots of lessons, hard lessons learned in the process.
And Rob, how about yourself?
I've been working in the field of data for over 15 years. I got my start working in big finance for Lehman Brothers, actually, when I began my career. Began working as a data integration developer, an ETL developer, a data architect, lots of different titles over the years. But I found my footing and grew in a path working for Major League Baseball Advanced Media for over 15 years, where I got to grow out a data team there and go from being the first hands-on ETL developer using graphical tools like Informatica to moving all the way forward to being able to realistically call myself a data engineer working with cloud-based data warehouses, orchestration platforms, and the like. So migrations have become a fact of life. It's not something that anybody particularly looks forward to, but if you are at the same company long enough or in this field long enough, you're going to encounter one sooner or later. It's a necessary evil, and it's certainly not the thing that anybody is specifically excited to do, but it is a means to an end that I have found the end is often where there's the real excitement when you've moved forward by orders of magnitude. So thanks for having me on. Excited to chat about it further today.
Absolutely. And Gleb, again, for folks who haven't listened to your past appearances, if you want to give a brief recap on how you first got started working in data.
Yeah, my first start was back in 2014 when I joined Autodesk's consumer group. At the time, that was division of Autodesk that was tasked at creating a portfolio of apps targeted at consumers for creative work, such as modeling 3D objects for 3D printing and other exciting things for creativity. And I was pretty much tasked with creating a data platform from scratch and for these portfolio of apps. And it was a really exciting time because I believe that was a year when Airflow was just released out of Airbnb as an open source project. And Snowflake, I believe, came out of stealth, and we talked to them very early. And Redshift was the hottest technology for warehousing. So a lot of things that are currently considered extremely foundational were cutting edge at the time. And starting data platform from scratch, I was able to explore and try out all these different technologies. That was very exciting. And then I moved to Lyft, where we've really tested a lot of these technologies, but at very large scale and quickly learned that we have to find more scalable solutions, which is pretty much how I got into doing a data migration.
And Rob, do you remember how you first got started working in data?
I think, like many things in life, it was probably a bit happenstance, as it was sort of where I began my career right after college, working on a project that was involving some back end purchasing systems, but ultimately then required data integration to be done. And it was an area that I found myself really enjoying. And so when the opportunity presented itself to start a team at Major League Baseball, I jumped on that. And after 15 years there, really building up the muscle for it, I recently got an opportunity to jump on as a principal engineer at Eventbrite. And sort of the thesis that I had was that all of the hard lessons learned over those years, doing several migrations, seeing several evolutions of the stack, would allow us to move even more quickly. And in jumping into Eventbrite, that's certainly been the case, been able to really accelerate the timeline around a migration and really see the effects of what moving to a modern data stack can offer an organization in what feels like record time. So I think the journey has been consistently about kind of knowing that change is constant and then being ready to adapt to it as needed.
And so, bringing us now to the subject of data migrations, migration can mean anything from I need to rename this one column to be something a little bit more understandable to I need to move petabytes and petabytes of data from one architecture to a completely different paradigm to I need to move all of my batch data into streaming workflows. And I'm wondering if you can just start by describing, for the purposes of this conversation, what constitutes a migration.
Yeah, I think for, like Tobias said, there are multiple flavors and facets of data migration. And I think data teams are constantly moving something or evolving their systems. I think that an interesting one to explore today, and I know that that's kind of the scope where both Rob and I have spent a lot of time thinking about, is when you migrate your data preparation workloads and your analytical consumption from one data warehousing system to another, or when you are adopting a new framework for data preparation. For example, you would be migrating from a system like Airflow or Informatica to modern frameworks like dbt. Or sometimes you would do both at the same time to modernize your data platform. I think if we start there, there's definitely plenty of challenges and know-how to discuss just within that particular scope. I don't know, Rob, would you agree?
Yeah, I think on sort of defining what is a migration versus what is not, I think you have to consider that you'll be replacing one system with another. I think that ultimately, when you roll this up to the C suite, they're going to be looking at this in terms of cost, right? In terms of are we able to replace a system that is costing us a certain amount in either engineering effort to keep the thing alive, which is often the case, or in actual spend with a vendor, and what are we replacing that with? And I feel like a migration is certainly not done until you've cut the cord on whatever the legacy system is. So I think it's defined sort of by the sense that it is not an incremental change so much as it is a wholesale replacement of one system with another, usually with one data platform for another in the case of data warehouse migrations.
And for people who are considering embarking on one of these migration projects, what are some of the signals that would suggest that that is necessary? And what are some of the cases where it is actually possible to avoid having to do that migration and you actually just need to invest a little bit more engineering effort into making your current platform maintainable and sustainable?
Yeah, I mean, I guess I can jump in here first and say that, as I said before, nobody looks forward to doing a migration, right? I don't know of any engineers, myself very much included, who say, ooh, what I really want to do right now for the next 6, 9, 12, 18 months is a migration project. It is something that is hard to get buy-in from executives because you're essentially going to be considerably slowing down the velocity of your team during this time frame. So what signals point to it really are about, is there an order of magnitude improvement available since the system that you are currently working on was created? That could be because there's a new emerging technology. For me, it was that we went from having at one point an on-premise Teradata server that sat in a big server room to moving to cloud-based data warehouses like BigQuery or Snowflake, where it's a complete paradigm shift in even how you run the platform. It could be that there's major production outages that are becoming so frequent that your team is constantly fighting fires with a system instead of being able to be productive to it. Could be the emergence of something brand new that we haven't even thought about yet. And I think that's what's so interesting, is that I've seen this pattern over my career. Basically every 5 to 7 years, there seems to be this evolution. And I feel like right now we're in this sweet spot where I don't think any of us can necessarily see past what the world of Snowflake and BigQuery and what's next looks like, but I'm pretty confident there'll be something. I just don't know what it is just yet.
Yeah, I think if we also try to kind of come up with particular reasons or like dimensions of that decision making, what I've seen myself in my career and also working with other teams, it typically comes down to probably three factors. One is scalability. So can your current system support the scale of your organization in terms of the size of data, obviously, the complexity of data, and also the performance around consumption of data? So can, for example, the users query the data sets and your, something as simple as dashboards get refreshed in a meaningful amount of time? And for us at Lyft, when we embarked on migration from Redshift to the Hive-based data lake, scalability was by far the strongest reason. Back in the day, Redshift was a system that had strong coupling between storage and compute. And that meant that whenever we had to increase the capacity of cluster to just have more data, we'd have to resize the entire cluster. That was a very scary operation that the data ops team had to perform over the weekend. And that took multiple hours to reshuffle the data between the nodes. And we got to a point where we were operating one of the largest Redshift clusters in the world. And the other facet of scalability where we faced really, really strong pain was around consumption. So again, back in the day, Redshift had a very concrete limit of how many queries could be executed concurrently. And at the time, Lyft was growing rapidly, and we had a massive adoption of data analysis across the company, primarily through tools like Looker and Mode at the time. And what happened was we'd have extremely high surges of queries starting 9 a.m. when people came into the office and were refreshing the dashboards and reports. And that completely brought the system underwater to the point where data team would have days where everyone was like, let's just go get Boba because Redshift will not be able to run any queries for another few hours. So that's the scalability part. And then the other, I think, important would be interoperability and in general capabilities of systems. I think Rob mentioned that sometimes you would see a completely new sets of use cases and capabilities that new system would bring, as well as the ability to just have multiple systems interact with your data. For example, with Redshift, it was hard for us to use other systems to query that data because the system was very closed. With more data lake architecture, so even modern warehouses like Snowflake, that's much, much better. And then final one is cost, but that I think is a very tricky one because in my experience, it's really easy to get misled by how much your system costs. And that could be a really misleading factor if that is your primary driver for migrations.
Yeah, I want to plus one a little bit on that feature set, rationale there. I think that's something that my team certainly saw as we moved at Major League Baseball from Teradata to BigQuery was, we did it primarily because of performance. I mean, as you mentioned, scalability again, too, just the ability to not necessarily have to worry about one stakeholder running a bad query that brings down the entire system, as in the case where a lot of systems that do couple the storage and compute have that problem today. So that was our initial onus for looking at a migration. But then the feature sets is really what ended up making it be as successful as it was, meaning that BigQuery offered us certain things, most notably button press data sharing. That at MLB, we used this to set up a system that we called Wheelhouse, where we basically kept our data pipeline centralized. So we would ingest data from ticketing vendors like Ticketmaster and Tickets.com, bring it all together in one place. And then we wanted to share that back out with the 30 MLB clubs individually. At one point, that was a system backed by good old FTP. And as we move forward, we started moving that towards S3 storage. But being able to move to BigQuery meant that we just clicked share on the data set and they had access to it. And so this was like a paradigm shift in how we would work. There was never going to be a question anymore of why is my data out of sync with your data, which was such a common problem with the previous system. So it really was, yes, performance, cost, scalability, but also like what are the features that this system is capable of that the other one, for whatever reason, just is not. And I think that was data sharing was a big one for us on BigQuery. Certain cloud data warehouses now have the ability to do time travel, which again is something that some others may not have. And that's a huge difference when you're able to not think about backups in terms of something that you have to go and ask a database administrator to pull for you, but you can just write a SQL query for. So those features completely change the way you work with the system.
And going back to one of the things that you said, Rob, about you don't want to bother with doing a migration unless you're going to get an order of magnitude improvement. You listed some of the types of features that will contribute to that measurement, but often it's not possible to fully comprehend the impact of the migration until after it's complete. And I'm wondering, what are some of the ways that you can do some early signals gathering to understand, one, whether your intended target is actually going to have the impact that you want it to what the actual overall cost difference is going to be. That's often the hardest one to figure out. And just some of that early work that can be done to prove out that, yes, this is a good idea and get some buy-in from the people who need to actually do the approvals.
Yeah, I think it's about finding the right proof of concept use cases early. And I mean, the challenge there is identifying a properly representative sample of workloads. At Eventbrite here, when I joined, the team was already underway with their evaluation of Snowflake and had already identified some key parts of our current data pipelines that were lagging, taking a certain amount of time, and we're able to essentially port subsets of those over, right? Quickly with these cloud data warehouses now, at least on this generation, what's nice is you can kind of commit to very little. In fact, when you first start out with BigQuery and Snowflake, you don't need to have a signed contract and a commitment for 5 years. You can just go ahead and do it on demand. And so I think that allows you to really experiment very cheaply at the beginning, right? You're just using the compute resources that you bring for trying out a workload, and you can hold those workloads up against their current workload counterparts. And you can really bring almost the full size of a subset of all of your data sets over. You don't want to, of course, bring over all your data sets. You're not actually doing the migration yet. But by finding that representative sample and bringing over the full size of that data, you can very quickly observe, hey, what is the cost of this? What is the speed of this? But, as you hinted at, though, too, like actually anticipating what the cost will be is very challenging early on. And you have to kind of keep adjusting that as you continue to port workloads over to see if you're within the expected range.
Going back to the question of cost, you mentioned the financial outlay of running this new system, figuring out what are the cost differences of actually operating it, but there's also the harder to account for aspects of time and opportunity cost. And I'm curious how you have approached that process of doing the accounting to figure out how much is it actually costing me right now, how much do I think it's going to cost me once I'm done with this, and how do we manage that differential as we move through the progress of the migration?
I think what is interesting is that the cost accounting kind of changes before you embark on the migration. So you're thinking, is it worth doing? And then as you go, probably when you arrive at the realization that you need to migrate, it probably because the current system inflicts a lot of pain on your day-to-day work. And for example, in the case of Lyft, our losses for not doing migrations were pretty clearly expressed in the productivity of the entire analytics team, as well as in the ability of the team to deliver insights and have the stakeholders query those insights in time. So one example is that, if there are meetings scheduled to review dashboards and metric at 9 a.m. and you can't deliver those because your system is just not able to perform all the necessary computations, then you have, a huge business cost that essentially means the company cannot make decisions in time. For a business like Lyft, that was extremely high. When we were embarking on migration, it was clear that there is an enormous opportunity cost of having the actual analytics and data engineering team internally perform the migration, because then they would not be building data products that would actually propel the business forward in terms of creating new insights and new models. And so I think in general, one of the most effective levers here data teams can pull is to try to outsource that work as much as they can, because otherwise you may lock down your entire analytical team in a project that doesn't necessarily have immediate user-facing impacts that could be challenging both, business-wise, but also politically for the team. You don't want to be in a world where for 6 months you're just working on this infrastructure project. And I think the third one is like once you are on the new system, how do you make sure that, or as you anticipate being on the new system, how do you make sure that this economically ultimately is feasible? And I think that is something that is easier to quantify with more modern warehouses, if we're talking about the warehouse migrations like Snowflake or BigQuery, because their pricing is transparent and ultimately it's fairly easy, like Rob said, to quantify what would it cost to move workloads between those systems, because you know how many queries you run, you know even how much data those queries are scanning. When these things get really opaque is when the system you're trying to migrate is sort of like a data lake, which is supported by some open source systems like Trino or Spark that you try to run internally. Those can be extremely complex and high cost projects, not only because you can't really estimate the cost of a query because you're running infrastructure yourself, but also you now bake into that the cost of ownership in terms of like data ops teams and DevOps teams that now have to maintain those systems. That's definitely one of the, I think, mistakes we've done at Lyft is we haven't really counted the true cost of moving to such an architecture and what would be the alternative for us in terms of, for example, embarking on a vendor that would provide a more final solution, like a query, for example, like Snowflake or BigQuery or other warehouses. So that's probably where the cost accounting fallacy can be the strongest.
Yeah, doubling down on that a bit, I think that that personnel cost of keeping the legacy platform up and running is one that could be very easily missed in the overall calculations, but it is one that was certainly felt at my current role at Eventbrite when I joined, given that the team was self-managing a Hadoop-based stack based on Spark, Hive, Presto, running it on AWS. So it's not like we were trying to run it on our bare metal, but and using tools like EMR, which do simplify some of the management of Hadoop. But there's still a lot there, and over time, it accumulates more and more technical debt as well in terms of sort of being pinned onto an older version of various tool sets because of certain dependencies you may have. And so ultimately for us, what we saw was that the team was just constantly burdened with on-call issues, right? On-call issues that would arise day and night due to the system not performing the things that we just simply expected it to do every day or every hour on a regular basis. So I think that cost was probably the most felt. And so I think everyone at that point was ready to welcome a managed service, taking that burden off of our hands. And I think that's one of those that it may be a little trickier to quantify financially because it's not necessarily like system Y that you move to is costing that much less than system X. But when you sort of try to bake in, well, it's basically taking us 2 or 3 full-time engineers' time to just keep this thing's lights on, let alone try to even improve it, which would be another set of engineers. Can we get that for free by just migrating? And that's where, again, that math starts to come into play.
And another aspect of this question of migrations, when to do them, how to do them, what to migrate to, is what are some of the early decisions in terms of the architectural design, the overall workflows that are built on top of these, the dependency chains and the hard requirements that you build into the overall architecture that contribute to the eventual need for that migration? And what are some of the lessons that you've learned in the process of going through these migration paths that have helped you understand as you reach that eventual destination, removing some of those potential pitfalls and architecting in some escape hatches to be able to get some further life out of those system architectures that you design that were previously major constraints on the sustainability of the previous platforms?
I think while there are multiple dimensions to plan here, personally, one of those that probably had the biggest, unfortunately, negative impact on my success as running migration is the decision of whether you are doing lift and shift migration or you're trying to improve things as you go. And just to double click into that, lift and shift essentially means that you have, let's say, 100 workloads, like 100 transformation jobs running on your legacy system, and they can be very ugly. There could be some like really big performance bottlenecks. The data model is probably makes you want to cry because it was built over the last 10, 15 years. But you say, you know what? I don't care. I'm just going to replicate those exact transformations on my new system. I'm just going to literally copy paste SQL and adjust it for, or, Spark or whatever, like adjust my code, make sure it runs on the new system, address any bugs. But ultimately, I'm just aiming for the same party, and I will take care of refactoring later. That's lift and shift pattern. The second pattern is you look at the system and you realize it is extremely inefficient. It is very badly architected because, again, it's just accumulated all your legacy work from the early days of your business. And you say, well, this is a great opportunity for us to improve things. And I think for data practitioners, it is very tempting to embark on the latter route. And this is what I have attempted to do at Lyft when I was tasked with architecting the migration. And that is a complete, in my opinion, road to disaster, because even if you're doing lift and shift, it is still a very expensive and complex project. If you're trying to re-architect things in the process, you are now essentially bottlenecking all these efforts on the ability to kind of re-engineer, refactor things, but most importantly, in larger companies, generate consensus about the new data models or spending time optimizing things, and that just exponentially increases the complexity of the project. So having burned by that, I strongly recommend everyone to do lift and shift. And I've seen other data teams that we support at Dataful do lift and shift and being extremely successful with getting through migration way faster than I was able to at Lyft. And I think the other one that I would also think is important is whether to outsource your work or not, which we touched on. And I think if you're doing lift and shift, that actually makes the migration workload very outsourceable, because you're just saying, look, I have the system on the left, I want the same thing on the system on the right, and you can outsource that to people who don't have context on your business. Again, my mistake was that we brought in consultants and I tried to employ them to make our data model better, because obviously they're experts and they have seen a lot. And that was also a disaster, just because having someone externally come in and work with your stakeholders to create better data models is just not going to work.
Couple of different threads that I want to go down. And so one of them is in terms of that dependency chain of, oh, we can't retire this old system because X, Y, and Z relies on it. One of the paths that lead to those, very obtuse dependency chains is giving data consumers too much access to the internals of the system to do whatever it is that they want to do, or the making the initial system too clunky, so people start embarking on these shadow IT projects where they'll just bring in their own tool and they have this deep dependency on something that's in your stack you don't even know that they're touching, and so when you turn it off, everybody starts yelling because it's broken. So one of the questions is, how do you identify those situations, one, but also how do you prevent them from occurring so that you don't have these deep dependencies and you can reduce the overall surface area of what you have to maintain and refactor during the migration? And then maybe as a second question we can move on to from there is, we've been talking very broadly about this concept of migrations. You have to make sure that everything works effectively, but I'm curious, what are the architectural components that you have typically seen as the major targets for these migrations, whether that's the ingest and load, the transformation layer, the warehousing layer, business intelligence? I think that makes sense as a second question to move on to after we've addressed how do you identify and possibly prevent these deep dependencies that have grown organically because of the fact that the system was so clunky to begin with.
Yeah, I think one of the first things you need to do when embarking on a migration project is spend some time really examining your system. And it's something that will unearth a lot of surprises, including, Tobias, as you referred to, that shadow IT that's occurred over time. Tapping back into what Gleb mentioned earlier, by doing lift and shift, you're at least not having to contend with the fact that you're going to have to communicate changes to downstream stakeholders at the time. In fact, the pattern that I've seen, and I'm 100% with you there on lift and shift, it's how I've successfully gotten through 3 of these in my career already, is by sticking to that. In fact, my current group at Eventbrite very much uses it as a mantra that is regularly chanted whenever anybody suggests even changing a column name. Lift and shift, what are you doing? So I think sticking with that allows you that even if you do have a nested web of dependencies, to minimize how much you need to really navigate that, because you're going to be basically exposing a system that essentially from the outside, from the interface of SQL, at least, assuming that we're sticking with a SQL based system, it looks and feels about the same to the end user. It's not to say that they won't have work to do, but the work can be minimized by the fact that the table names look and smell and feel the same. It's why one of the first steps that I've usually taken on any migration I've done is to set up basically a replication of the legacy system into the new one. And when we do that, again, sticking with the lift and shift pattern, one of the really big benefits there, we had talked about opportunity cost earlier on, is that as soon as you have a complete replication of the core sets of tables that are in your legacy system, replicating into the new system, and that can be at a daily cadence or an hourly cadence, whatever makes sense, but you set that up first, you can switch all your consumers over to the new system. And this is what we've done at Eventbrite here, where we basically set up Snowflake last year and set up replications from our legacy Hadoop-based platform to it. And then we basically gave all of our consumers a 3-month window to say, listen, you've got two systems that look and feel the same right now, but in 3 months, we're going to cut you off from the old one. So you've got some time, raise your concerns, raise your complaints now, or forever hold your peace. And that is when the shadow IT emerged. And that is when we found out about plenty of teams that had their own one-off Python processes running on a Windows scheduler somewhere that actually were responsible for huge pieces of our business, and we just didn't know about them. And so it sort of forced those things to come to the forefront, because we at least then needed to talk to them about how they were going to switch their connection over to use Snowflake now instead. So it's sort of, what was shouting from the rooftops to our organization that, like, hey, this change is coming. It should be minimally impactful because things look and feel the same, except things will be faster on the new system. But we need you to self-identify now, because we're going to turn the lights off for you as a consumer on the old system early. Now, at that point, we're not done with the migration. We haven't even talked about moving the transformation or ingestion layers over to the new system yet. But by doing things in that order, you make sure that you identify very early on in the process who are some of those dependency chains further on down your path. And then you can kind of focus on the ingestion and transformation rewrites in the background, while all your data consumers have already moved over to the new system. And in fact, the biggest challenge we have now is that everybody thinks we're done with the migration already because they're already using the new system and they're happy on it. And we're like, actually, the data is still going through the old system and then copying to the new system. But from your end user perspective, you get the fast, improvements and new features of a new system right away. So it becomes more of a carrot than a stick of like, don't you want to move on to the new thing? It's faster, it's better. And then eventually the stick comes of like, all right, we're kicking you out of the old system now.
Another element of these platforms, one that I'm currently dealing with, is the question of access control and governance, and those can be implemented very differently depending on what the underlying technologies are, the specific access patterns, where if you're piping everything through the warehouse, you can say, okay, I'm going to implement my control here, or is all of the control implemented in the business intelligence layer, or do I have to do this at some more granular level? Am I relying on some sort of single sign-on, whether that's via OAuth or Kerberos or SAML? I'm curious what you have seen as the role that governance and access control have played in the migration projects that you've been involved with.
Well, I can kind of jump in first and just say lift and shift, right? Like, whatever it was before is what we're doing on this one. And I think that mantra helps you get past some of this inertia and say, yes, like we know that at Eventbrite, moving to Snowflake gives us new opportunities for things like row level access control, PII redaction, things that we couldn't do on our previous system. We're excited about those features, but we want to maintain that parity right now. So that sort of becomes not part of the migration project then, right? It becomes whatever the access patterns were before. If this set of users had access to this set of tables, let's keep that for now because we want to make sure that the migration worked successfully for those users. And then we can kind of embark on follow-ons to further whittle that down. The authentication piece, as far as how they get into the system, might change, right? But the authorization piece should not.
Yeah, I think the question of governance actually is, in my experience, less important in terms of can we implement the governance on the new system, but rather how does the data governance affect the complications of migration? For example, typically the vast majority of workloads on the system are not related to transformations, which are, let's say, in more or less control of the data engineering team, but in the consumption layer, right? So notebooks, one-off query exports, BI, and dashboarding. And the patterns that are used by those workloads and the capabilities and the choice of those systems actually dictate how costly would it be to move those workloads over. For example, at Lyft, we had two systems at once. We had Mode, which is a very notebook-driven workflow, and we had Looker for the primary dashboarding, kind of standardized reporting workloads. And moving Looker workloads over was extremely simple because it's mostly templated and it controlled by the internal semantic layer. So yes, you had to make some adjustments, but those were minor and those were easy to do for the majority of the workloads and the majority of the consumption, dashboards and other nodes. With Mode, I remember we had a question of, well, analysts love it, so can we figure out like how many reports we need to migrate? Is it like dozens of reports, hundreds of reports? And I did like a kind of a hacky lineage project where I did analysis of the API and try to figure out just the scale of dependencies. And I uncovered 13,000 notebooks that were created and actually actively running on the system. And those notebooks had pretty much like no governance in the sense that if you wanted to switch them over to a new system, you had to pretty much go into every notebook and every Solvit notebook and rewrite the SQL to query, change the dialect from like Redshift to Snowflake. So that was not at all possible to do in any kind of centralized fashion. And so we had to pretty much resort to what Rob says, right? Tell the users to migrate those over. And that was obviously a very high friction exercise for the stakeholders and one that actually really slowed down the consumption adoption of the new system.
Another aspect of migrations is deciding when they are done. To your point, Rob, some people might say, oh, it's done because I'm already using the new thing. But you say, oh, I've actually still got months worth of work to do. So I can't actually fulfill the request that you just sent me that you think is only going to take me a few minutes. And I'm wondering what your strategy has been at the outset of the migration to be able to define these are all the things that need to be done. These are the ways that we're going to validate completion, and this is what we're going to use to measure overall success. And then also in that path, what are some of the early maybe break glass situations that you have identified to say, actually, this is not going to work out the way I think it's going to be. I'm going to cut bait. I'm not going to fall victim to the sunk cost fallacy and just keep bullying forward, even though it's not going to do work, and maybe step back and reconsider the overall migration effort.
Yeah, I think in terms of like knowing when you're done, the definition of done, it really is that the legacy system is gone, right? Gone from your budget, gone from your management, gone from being a thought in your mind, right? And I think like anything short of that means that you're not done. However, again, as I described earlier, there are different perspectives that different stakeholders can have on that help relieve that pressure. I mean, again, by having the replication in place early, there's not this built up expectation of, oh, that team's working on a migration, it's taking forever, and I can't see any results, right? You want to minimize the time that it is something that is invisible to others, and you want to start building that internal advocacy for it early. Or in what you described, I haven't encountered this on my own, but get that internal feedback that it's not working well for a use case early on, right? And make decisions about that. So I think it really is about, by first doing this really kind of simple lift and shift replication, you can let all of your stakeholders and all of their workloads onto the new system and de-risk that a ton, because you then find out right away about any challenges, any problems they may be seeing. And you also then relieve a ton of pressure of, all right, I've invested in this new thing. I'm now paying a bill to Snowflake every month. How come I can't see anything from it yet, right? How come nobody's using it but the data team right now? What is that, right? So like you try to minimize that time that you're doing that replication stuff, which I think really helps, and also gives you opportunities to like throw different types of workload at it and navigate them. I remember at MLB, for example, we still had some of our data science team using a set of tools from SAS. I mean, this was kind of stuff they had used prior to really Python and R becoming as widespread as they were. And as we moved to BigQuery, we kind of learned, oh, wait a minute, the connector from SAS to BigQuery is not really what we want it to be. And we identified a pretty big risk there of like, all right, well, all of these workloads really are not working the way we intend them to. Can we find a fix for that, right? Can we get past that? Is there an additional cost to license something that will get us past that? So again, I think it's about just getting your data stakeholders in there as early as possible to at least de-risk this.
Yeah, I fully agree with Rob in terms of setting let's turn off the old system as the actual goal we're aiming for, because as long as the old system is running, it probably still incurs high costs in the business, and it's hard to say that we've completed the project. I also think that because that kind of 0 to 1 can take months and sometimes years, it's helpful to also kind of set the goals in terms of how do we measure completion or even our progress within the migration. And if you want to do that, probably the atomic element of migration is, let's say we're migrating between warehouses or migrating between transformation frameworks. It's probably migrating the tables that are produced in the transformation process, right, as part of our kind of the transformation DAG on Airflow or DBT. So a single job that produces a single table kind of becomes this atomic unit of work that we can count as either done, in progress, or yet to do. And then some BI workflows as well, right? Like, have you migrated the exact KPI dashboard or not? And what I found that if you are doing a migration of these atomic blocks within a large organization, the process that becomes really critical is user acceptance testing, which is kind of known in software, but in data, what that means is if you migrating a workload, let's say you probably have like a set of tables that are really, really important, right? And you try to get business use them. First, let's say, like Rob said, if we just replicated the the legacy produced data sets to the new system, when I try to have people switch their consumption to those tables, we have to convince them that, assuming the lift and shift pattern, that's the same data, right? They can trust it. There are no regressions. There is no kind of like we optimize the definition of conversion in the process, right? It's still the same data. And that kind of user acceptance, creating a process for that and making sure that stakeholders explicitly get you a thumbs up, or you have a certain way to signal to your stakeholders, yes, this is the same data, you can use it, is quite important. Back at Lyft, we were writing a lot of custom build software for that because we just had to, no one would trust that we produced good data. We actually had to present this as almost a dashboard that said, yes, this table is exactly the same as your same table, but on the old system. So now can you please switch your report? Or can you please switch your machine learning job to it? And that was actually one of the inspirations for me to build a tool called DataDiff at Datafold, which essentially produces the same analysis, but fully automatically for the user. And you can do this within database or cross databases to actually answer the question, is your data the same for the purposes of the user acceptance testing? Also, I'm curious to hear how you think about the UAT, Rob, given that you have fairly large company and a lot of stakeholders you have to convince that you've actually completed the work.
Yeah, I mean, at my current role at Eventbrite, DataDiff, both the open source and then the commercial product of Datafold, have been instrumental in something that, like Gleb mentioned, you otherwise end up engineering yourself. At Major League Baseball, we did exactly that. We didn't have Datafold or DataDiff, so we built tooling, because we're engineers, so we always want to build a tool to try to get through anything that we might have to do manually. We built tools that generated SQL that attempted to compare the way the tables looked, really that we built a very primitive version of what DataDiff does. And we did this because we needed to be able to be confident in what we had been replicating. So we use, in my current migration project, we've used the DataDiff and Datafold tools in two different places. One is when we're first doing those initial replications, as Gleb described, to build confidence that the old and the new systems are matching, that your replication processes themselves are valid. Eventually, you gain confidence in that because your replications start to look a lot the same. If you're replicating 1,000 tables, once you've got something set up for it, you know that your process is working well. But it does unearth lots of problems along the way that you would have. Time zones are an old favorite. They always seem to give you an issue. Things like that, character encodings you might have missed otherwise. Once you're in the midst of the migration and you're actually rewriting your transformation logic, the ability to, again, have a replicated copy of what the output was from the old system and then compare that with the output of the newly written transformation logic and basically look for row by row matching because you're doing a lift and shift is huge. And it's something that honestly, and I don't want to go on record and say that I love doing migrations, but there is one part of it that I like, which is that there is a ground truth to hold yourself to, which is that if the old system is assumed to be accurate, which by the way, that assumption can be wrong sometimes. We've found plenty of bugs in the old system as we move forward. But if you assume the old system is accurate, then you actually have this ground truth to compare your results against. And I feel like that's something that working in data, you very much don't always have. If you're building a brand new data pipeline, the best you can do is do heuristics and metrics on it to see if you feel like it looks like it's correct. But in this case, you have an exact copy of what that data should look like to tell you that it's correct. So it's actually a really nice place to be when you're in migrations. And to the point you raised earlier, why it's easier to sort of spread out this workload to others who might not even be so familiar with the domain of the data, because they can use tools like this to do an exact comparison.
And speaking a bit more to the automation question, you talked about being able to use data diff to be able to validate that the old system and the new system are in agreement and that all of the same data is present. What are some of the other places where automation can be useful? And what are some of the ways that you have seen automation employed where it is actually a net negative?
Speak to one other place where I've seen it be incredibly useful, which is in the translation of a SQL dialect, for example, from one system to another, assuming we're talking about a migration from a SQL-based data warehouse to another. At Major League Baseball, we had hundreds of SQL scripts of thousands of lines of code each sometimes that were written in Teradata's dialect of SQL. And at that point, we were working with Google Cloud, and they ended up actually acquiring a company called CompilerWorks. I believe they've been on the podcast before as well. And they had a tool that would understand and parse the SQL syntax tree and then turn it into another version of SQL for you. And it was pretty advanced. We were always blown away by how far it could get because there were certain features, SQL qualify clause that Teradata had that BigQuery just didn't have at the time, that it would then completely rewrite your query into like a nested CTE in order to get the same results. And that's just a game changer when you're not going through the tedium of like trying to find SQL differences. At Eventbrite, I was able to kind of engage in a much more simple version of this because we were moving from Presto SQL syntax to Snowflake SQL that were actually a lot more alike than they were different. And so here, I basically built an internal tool that used mostly regex expressions just to change out certain things that were slightly different. It certainly wasn't as advanced as something that would parse the entire SQL syntax tree, but it also didn't seem to be necessary. We got 90% of the way there with that. I know there's also a tool and framework out there, SQL Glot. I believe he's also been on the podcast. That same sort of thing, being able to transpile SQL from one dialect to another can save you, hours of frustration and having to do something that would otherwise be very tedious.
Yeah, +1 to SQL Glot. I think if I had this available in the early days of my data engineering career, that would be a game changer. But I did get to use CompilerWorks at Lyft, which was definitely helpful. And yeah, I think the other aspect of automation that can be helpful in the planning phase is data lineage, because ultimately, whether you're doing lift and shift or whether you try to refactor things, you have to plan and sequence the migration, and you have to decide of hundreds and sometimes thousands of your jobs, which ones you're tackling first, which ones you're tackling last, and which ones you may not even need to tackle and you can probably deprecate because they were like one-off things that were built. And having data lineage that essentially allows you to see the dependencies within your data stack, both in terms of the transformation layer, how models, how tables are dependent, as well as going into the consumption layer, so understanding, well, is this table that gets produced actually queried by any of the BI tools? And if it is, are those tier one executive reports querying it, or maybe those are some one-off reports that haven't been even touched in months? Well, incredibly valuable. Back at Lyft, we did use CompilerWorks that was at the time, very cutting edge technology, and that did save us, I would say, unimaginable amounts of time of otherwise having to migrate over 10,000 models without any kind of good insight into the dependency tree. This is also a capability that we now offer as part of Dataflow that can be helpful for teams that are planning the migrations between the warehouses, between the transformation frameworks.
+1 about the value of lineage, although I think the challenge that we've had is that you're then trying to apply lineage onto the same legacy system that you're fighting with as it is to get off of, right? And so in the case here where we looked at could we apply a lineage tool onto our legacy platform and get value out of it, and that was an example, Tobias, you asked when we decided maybe that it wasn't worth it. We were looking at what it would take to actually deploy the lineage tool on the legacy system and then what potential strain that might add. And, when you're looking at a legacy system that you're trying to move away from at that point, you're afraid to look at it the wrong way or breathe on it the wrong way for fear of the whole thing toppling over. And so I think we started looking at could we apply lineage here? Could we use some of these tools to help us untangle this? And we ended up deciding against it. We just said the amount of effort it might take and the risk that it poses to putting that onto the legacy system isn't worth it. So we essentially, in our case, basically had to manually craft that. You definitely need that lineage graph in order to be able to do this migration. It's just about a matter of whether or not you can bring in tooling to help you do it. Because I think once you have that lineage graph, it then becomes critical in sequencing your order of operations during the migration. Most importantly, when you look at your set of data jobs as a web of dependencies, the things that you can start to migrate and turn off on the legacy system first are those that are the edges, the leaf nodes, the things that no one else depends on them. So if you have table A and table B, and table B depends on table A, you can't turn off table A first because table B's stuff will break, right? So, but you can, if nothing else depends on table B, you can move that over and actually turn it off first. So really being able to visualize this, and it doesn't have to be a fancy graph. It could just be, in our case here, we're using a Google Sheet where we just keep track of this and constantly keep looking for like, all right, now that we've moved this thing off, these two things have now become edges. They've now become leaf nodes. We can now consider moving them next. And so you definitely need that. It's just about whether or not the tooling can help you with that or not.
And in terms of your experiences of going through these migration projects and working with other people who have gone down similar paths, what are some of the most interesting or innovative or unexpected ways that you've seen these projects approached or implemented?
I'd say that honestly, this is one of those places where I'm not sure that interesting is better. I think that there's sort of when you've been through a few of these, it's almost like there is sort of a process to it. I kind of alluded to it of just, replicate, then get consumers over, then start working through your ingestions and transformations, validate along the way. It feels like sort of following that playbook has led me to success on several of these, whereas I'd be concerned about trying to deviate from that. Even in early days, just discussing how we would approach the migration here at Eventbrite, we had other ideas, but we kept coming back to this of like, listen, this is a well-trodden path that worked. So I mean, I think in terms of like surprises that we hit while we're working on one of them that's a very pleasant surprise usually is how many things you can deprecate. Gleb talked earlier, I think, about thinking of those atomic units of migration in terms of tables and jobs. And okay, you might start and take an inventory and say, I've got 10,000 tables and 500 jobs. But then you might think, okay, the work is now I got to estimate out if each job is going to take me a week, I've got 500 person weeks. But one great thing is you can kind of cut down that denominator by just saying, we're not going to migrate this thing. We're just going to kill it right now because nobody's actually using it. And I think that self-reflection on a data system is something that you usually, as a data team, don't carve a whole lot of time out for. If a job isn't broken, it can be running along the way for years before anybody ever looks at it again because no one's going to put the Jira ticket on your board to go look at something that's not broken, right? So like, I think the surprise of actually we can cut off, in the case of Eventbrite, we had over 10,000 tables in our Hive schema. We only brought over about 1,000 of them to our Snowflake data warehouse. And, we were concerned in the month or two we talked about previously that people were cutting over, that they might be complaints. I think we maybe got 2 or 3 hands raised of like this one table I'm missing, right? But like that meant that the other 9,000 were not providing anybody any value that we were aware of. And so like that was a surprise of just how much is there, how much data is cheap to store. And so you end up just storing it kind of forever in a lot of cases like that.
Yeah, I strongly agree with Rob on that one. The boring is better. Doing lift and shift and really taking discipline and not trying to solve problems, other problems, but to move things over is important. And that also, with one exception of deprecating things that are not used, because that's like that can really massively, for example, Rob's example, right? 10x reduce the complexity and cost of the project. I can say from the perspective of building data diff and seeing multiple teams leveraging it for migrations, I would say one thing I've been in generally very impressed how effective a well-run migration project can be. Like if you do lift and shift, and if you are very diligent about kind of mapping your dependencies and getting user acceptance testing from stakeholders, and you are using tools to automate the process, I've seen incredible velocity achieved by teams, like for example at Eventbrite, that I haven't been able to do in my career. That's been definitely very inspiring. And the second aspect of I think seeing how data diff is leveraged in those migrations that I haven't anticipated is when we built the tool initially, we thought of it as a very kind of developer first tool where, let's say if I'm a developer and I am working in a particular table, I would convert SQL, I would run the table, then I would trigger the data diff and I would get results. And we thought of it as a very developer workflow. The interesting use case for that I've seen was that companies also basically ran data diff on schedule for their entire scope of data models every day. And what that gave them is a pretty good estimate of, okay, what are the tables that are currently migrated? What are the tables that are in progress? And how far off we in saying we have full parity between systems at scale? Because then you can say, okay, like this, one of the, this table is like 99% there, but there's like 1% discrepancy, and we know where the discrepancy is. And pretty much like running this for the entire scope of tables is something that I haven't thought people would actually do, but it makes a lot of sense to actually implement during the migration to track your progress on the overall project level.
Yeah, we're one of those customers doing that, and we're the ones pinging you and your team, Gleb, if we're throwing 5,000 API requests against Datafold all at once and breaking the system in some way. But yeah, we did find that we did bake it in very much as part of the validation and basically configured alerts if things were off, and hopefully we never hear those alerts. So it becomes almost like an ongoing validation, which again is one of those beautiful things you can do during a migration because you have two different things to compare that, going forward, obviously there's tons of talk about data observability and testing tools, and it's a whole separate topic to uncover, but it's much tougher to figure out exactly what the test, whereas here it's just correctness by matching at 100% on column by column basis that Datafold can tell us.
In terms of your own experiences of going through these migration projects, what are some of the most interesting or unexpected or challenging lessons that you learned in the process?
I think for us, and that kind of speaks to the earlier question of how do you choose the technology to migrate to, one of the things where we struggled was the user experience of the new system. So at the time, we knew that we had to migrate from, originally was coupled storage compute system into a data lake, which would allow, much greater scalability, theoretically infinite scalability for both storage and compute. And the engine that we chose to do the majority of the lift was Hive. That was back in 2016. So, right now, some people probably haven't ever heard of Hive, but at the time, it was probably one of the more popular data lake engines that was very mature. They were also Presto/Trino and Spark, but they were kind of less stable and more cutting edge, still kind of getting their ground. And the trouble we ran into is that Hive was fairly good at tackling jobs at scale, but it had a really poor user experience by modern standards. It was very slow, and because it was slow to run queries, it was also slow to fail. Like basically would take sometimes 90 seconds for it just to return the syntax error. And the trouble of that is when you're doing a migration, you have to be able to iterate really fast because you're, converting SQL, you're running it. Let's say you're running a data diff and then you adjust things as you go. If your system is slow and is slow to fail, slow to turn errors, slow to produce results, that has a massive impact on the speed of the entire project. And then the other aspect of it is that Hive was a system that required a lot of the expertise in using it correctly. For example, it had like all these tuning parameters, and no one today probably would choose to use Hive. So I think the lesson learned is that today you can choose between, awesome systems of different kind, but really being cognizant of what is the persona you're optimizing for, who is going to be doing the migration, who's going to be using the system, and making sure that you have a good match between the technology and their technical aptitude. Because if there's a steep learning curve, right, for example, maybe you just decide to run your transformations and express them in something like Flink, right, because it's a very powerful system. But the majority of your team may be accustomed to SQL, and so having this learning curve, having them to learn new system and not being able to iterate quickly can really, really massively complicate the entire project. So that's definitely a hard lesson learned that I would caution modern data platform architects about.
We touched on this a little bit, but in your experience of going through these processes, what are either some of the design patterns that can help prevent the need for eventual migrations? And what are some of the ways that the tooling and technology that is in common use can be improved to make it easier to do these migration projects, or extend the overall runway and lifetime of the technology to prevent the need for these migrations?
Well, I think sometimes the tooling is almost serving the opposite effect of locking you further into what you're currently on. I mean, I look at, Snowflake just announced their dynamic tables feature and it looks amazing. But the flip side is, all right, the more we start to use the features that are specific to that platform, the harder ever moving away from it will be, right? I think in using Google Cloud and BigQuery, similar, we got really obsessed with the ability to use connected sheets and have G Sheets basically be, a very simple interface for our analysts to do mappings of data and things like that. And I think, if you're not careful, you start leaning too far into a vendor specific feature set, you make yourself very tightly coupled to things that are specific to that vendor. Now, luckily on the flip side of that, these vendors seems to all be in an arms race where, whether you call it Lakehouse or not, it seems like everything is kind of converging on a union of all possible features. So maybe that won't be such an issue, but it's something that I think you have to look at least a little bit skeptically of, like, as I move away from something that is just SQL on a set of data to anything else than that, what am I potentially complicating for myself down the road in moving away from that if I ever need to? So it's just something to think about, how do you sort of decouple some of what you need to do from a compute standpoint from what the system is then offering you in terms of automation on that?
Yeah, absolutely. That's a challenge I'm dealing with right now. Of, hey, this vendor is adding all kinds of new features on top of this underlying open source project that is what led me to choose them in the first place. But the more I lean into all these fancy new capabilities that they have, the harder it will be if I ever decide I need to just run the open source project myself.
Yeah, I think that today the vendor lock-in is almost inevitable, at least in certain level of your stack, right? So of course you have a vendor lock-in by just using a platform like AWS or Google Cloud Platform, but no one is really saying that I'm going to just run my data center with Linux so that I don't have this vendor lock-in. So, but at the same time, at the other extreme, you probably don't want to use a vendor who has a very closed ecosystem that gets, makes it like hard to get data out of. So the probably the middle ground here is that for critical systems like warehousing or business intelligence, where you can have a very deep vendor lock-in in a sense that the longer you are using a platform, the higher the cost is to migrate out. There are probably certain dimensions that are really important to consider. Like, for example, interoperability with other systems is huge, right? So is this technology just like a really advanced one that you love as an engineer, or is there a large ecosystem around it? So yes, I think with Snowflake and with Databricks and BigQuery, Google Cloud Platform, there's a huge risk of, like, if you really invest in it as a business, it's going to be extremely expensive to getting out of it. But at the same time, all of those systems have enormous ecosystems between them. They're also very competitive in offering features that kind of close the gaps. Once someone releases a new feature, then the other one will do soon. And so I almost want to say something like corny and say, like, you can't go wrong with one of these big players just because you will probably get enough of what you need. I think when things get tricky is once you kind of deviate from, like, okay, you have these foundations and then you have to build kind of less obvious parts of the stack and what technologies you choose and how that supports your business going forward. So for example, when you choose a transformation framework, that also has a fairly high migration cost. So if you, for example, choose dbt or Airflow or Dagster for expressing your transformations, migrating those could be as expensive as migrating from between the warehouses. And making sure that when you choose a framework for transformations, you think that it can actually support your business going forward. And for example, if you start with dbt and SQL, how does that then map into your longer term roadmap and types of workloads you want to do? So specifically in my dbt's example, they also have a pretty great ecosystem, and a lot of the tools that I would say like more advanced, for example, Dagster, they can actually interoperate with DBT, import DBT project, but then allow you to do other things. So in many ways, the stack assembles itself quite nicely in not letting you down, but it's definitely something that you have to be careful about when you choose parts of your stack.
Absolutely. Are there any other aspects of this subject of data platform migrations, the technical and organizational aspects thereof, and your experiences of embarking on these projects that we didn't discuss yet that you would like to cover before we close out the show?
And I think one thing I kind of touched on it before, but how important it is to sort of build an internal advocacy for your migration early on. It's so important because then you end up riding that wave all the way through the pain of having to validate everything along the way. And so I think that that's something that maybe, I don't know if I'd say it was a surprise. I think it was somewhat how quickly when you roll out a new system like this and start initially nagging engineers to switch their things over to use it, how much it becomes less about sort of forcing that behavior and more about them becoming advocates on your behalf. And I think that's something that is just really, really important because it gets you buy-in not just from senior leadership but from the sort of ground level up the other way too. And so I think that's really been key to success on these things, is just being able to let everyone see the value of it early and often.
Yeah, can't agree more with that.
All right. Well, for anybody who wants to get in touch with either of you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get each of your perspectives on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I feel like for me, it's still about the right development workflow. And I know this is something that everyone has different solutions for depending on the tool set you use. And as we move forward, I've seen evolutionary steps in this. Things like Snowflake zero copy clones allow workflows to be possible that just weren't possible before, but still forming that into like sort of a common set of development patterns. It feels like we're still a ways off from where the software engineering community here is on this, on being able to press a button and basically create a branch off of your data. And I know there are tools and technologies that do exactly this, but trying to get that in a standard way that then makes development trivial, makes it easy to onboard developers, makes it easy to try things out without having to incur the cost of spinning up a full new environment per developer. I think it's something that there's still a lot of room, and it's something that my team at Eventbrite has basically had to build our own version of this. And I think many companies are probably doing the same right now because there isn't a single right way to do this that everyone agrees upon just yet.
Yeah, I would strongly agree with Rob. I think the developer experience on data is in general way behind the productivity of software engineers with the tools that support them. And even if we set the kind of the recent advancements of LLM and Copilot aside, just in general, the basic things that software engineers could take for granted are not available to data engineers for the most part. Like even syntax correction for SQL or dependency analysis, that just doesn't really exist for the vast majority of workflows. I think that it's getting better with the standardization on certain frameworks like DBT, where the framework is fairly opinionated, which allows to build more opinionated developer experiences and allows vendors and other consistent players, including Dataful, to plug into that standard and then offer developer support in particular parts of the workflow. For example, the concept of data diffing we brought to DBT developers and allow them to diff as they go to see how the code changes impact the data, which is available as an open source package and as a VS Code extension. But I think we're still scratching overall as the community the possibilities of how great the data engineering workflow can be with the right tooling support. I think we're just starting on that journey.
All right. Well, thank you both for taking the time today to join me and share your pains and successes in going through these data migration projects. As you said, it's something that all of us are inevitably going to have to deal with. So I appreciate you sharing some of your hard-won lessons and wisdom from that. And I hope you enjoy the rest of your day.
Thank you so much.
Thanks so much, Tobias.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.